going to derive the volume of a sphere. The volume of a sphere of radius r is, and we're going to find out what it is. Maybe we don't know the proof. So, if you take, say, your semicircle and you rotate around the x-axis, you rotate around the x-axis, maybe that one was way too big, you are going to get a sphere. Okay, this is going to be a sphere. You know why? We can even just rotate what's in the first quadrant, and of course we'll get half a sphere, and then we'll double it. So the volume is going to be 2 times what we get from finding that volume. And that volume is going to be obtained from an integral. Now, we know that, so let's put the circle or quarter circle that we're going to rotate in the first part. We're going to rotate this around the x-axis. We're going to rotate that around the x-axis. That's R, Y, and 0x. Now the equation of that circle is y is equal to r squared minus x squared square root. And we are going to make slabs. We're going to take this rectangle, let's draw it that way, and rotate it around the x-axis. So we're going to have a delta x. That tells me right away we're doing dx. And we're going to take this rectangle and revolve it around the x-axis, and this one, and this one, and this one, and that one, and this little one. If you notice, the x values of those slabs are going from 0 to r. I mean, we're going to have a lot of them. We're going to have so many of them that it's actually going to fill in that quadrant. The x is going from 0 to r. So let's write r. Now, what is the height? So we know the formula is going to be pi times r squared. Leave some more room for r squared. When we rotate this type of slab, we get a disk. And the volume of the disk is pi r squared. Now, what is the radius of this disk? Well, the answer is pretty simple. The radius of that disk is y. The radius of that single disk. The radius of that single disk is y. In fact, that's true for everyone. This radius is r. This radius, is y. It's always the height. So we get pi times the radius, which is r squared minus x squared. The nice part is, so we have integral from 0 to r, and I can pull out the pi. The nice thing is when we square this, we are going to get r squared minus x squared. Now, r is always bigger than x. Okay? Because x goes from 0 all the way up to r. That is, r at best or at worst is 0. When x is r, this is 0. That's why I'm not getting x squared minus r squared, or I'm not taking the absolute value. Think about that. dx. Okay? So we have 2 pi. Now, the integral of r squared in terms of x, r squared is a constant. Get r squared x. Minus the integral of x squared is x cubed over 3. And this goes from 0 to r. Now I can factor out that 2 pi. First I plug in x for r, get r squared times r, which is r cubed, minus r cubed over 3, minus, now I plug in 0 for x. R squared times 0 is 0, minus, because it does say minus, 0 cubed over 3 is 0. So basically that's gone. Okay, so over here, I can factor out an r cubed. So I have 2 pi r cubed. But then I have 1 left minus a third. 2 pi r cubed. 1 minus a third, you should know. It's 2/3. So now we're almost done. 2 times 2 is 4 times pi times over 3 times r cubed. That's the volume over cubed. 4/3 pi r cubed. 4/3 pi r cubed. And let me be crystal clear. The volume of the cube of radius r is 4/3 pi r cubed. And so you don't